Hi guys, and welcome to our area review. Remember, I will only be reviewing the questions that were circled on the review, and it's your responsibility to do the other ones. If you have questions, come see me after school. Or actually not after school, before school. Alright, so here is number 1. Now this is a question that we've had a couple times and people have been struggling with it, so I just kind of want to point out a couple things. First of all, that this is a parallelogram, so this line is parallel to that line. And that makes this portion of the parallelogram a transversal, which means that this angle right here is congruent to this angle right here. And that's what we're going to be dealing with when we solve this problem. Okay, so when we look at that, we want to see what is the information that we have and what is the information that we need to know. So we know that this is 5 because that's a parallelogram. What we want to do is we want to go ahead and solve for this angle because we also want to know what this angle is. Okay, so we know in order to solve for that angle, we're going to find the sine of x is equal to 4 over 5, which means that inverse sine of 4 over 5 is equal to approximately 53 degrees. Okay, so that means that that angle is 53, this one is also 53. Okay, so now we are going to go ahead and solve for this x here. We also know that this is 8, so we're going to do the sine of 53 degrees is equal to x over 8. So that means that x is equal to approximately 6.4 inches. Okay, on to number 3. Alright, so this one, we have a triangle, and if we're going to find the area of a triangle, remember we need the base, which is 10, and we also need the height, which is x. But we don't have any other information in which we can use to solve for x. So remember that crazy formula that we used, called Heron's formula. So the first thing we're going to do is we're going to solve for the semi-perimeter, which the semi-perimeter is equal to the 3 sides, the sum of the 3 sides, divided by 2. So our semi-perimeter is 18. Okay, now we're going to plug that into Heron's formula, which is the semi-perimeter, the square root of the semi-perimeter, multiplied by the difference of the semi-perimeter in each of the 3 sides. So 18 minus 14 is 4, 18 minus 12 is 6, and 18 minus 10 is 8. Okay, now what I would do is I would go ahead and before you start multiplying out is taking these factors and breaking them down. So 9 times 2 is 18. We can leave 4 the way it is. 6 is 3 times 2, and 8 is 4 times 2. Okay, once you get done with that, you end up with the area is equal to 24 times the square root of 6. Alright, so we know that 24 times the square root of 6 is equal to 1/2 the base, which is 10, times the height, which is x. 1/2 of 10 is 5, so 5x, we divide each side by 5. That means that x is equal to 24 times the square root of 6 divided by 5. Alright, so here we go, triangle again. Remember, to find the area of the triangle, we need the base. Base is 32, and we need the height. We don't know the height. The height is going to be x. Okay, so it's giving us information. We're going to use this side of the triangle, this distance here, to find x by using Pythagorean theorem. So that means that x squared is equal to 17 squared minus 64, or 8 squared, sorry, which is 64. So x squared equals 225, x equals 15. Okay, so that means that this is equal to 15. So that means that the base of the triangle is 32, and the height of the triangle is 15. So we're going to do area is equal to 1/2 the base, which is 32. Remember, don't include that 8 because that's not part of the base of the triangle, times 15. And when you multiply that out, you should get 240 centimeters squared. Alright, here we are on to number 5. So number 5, again, we want to find the area of the parallelogram, and to find the area of the parallelogram, we need the base, which is 15, and we also need the height, which we don't know, so we're going to call that x, right? So what we're going to do is we are going to use the 10 and the 52 degrees to find this, the value of x. So we are going to do sine of 52 is equal to x over 10. So that means that x is going to be equal to, okay, so x is equal to approximately 7.9. So this is 7.9. Then we're going to do 15 multiplied by 7.9, and that gives us approximately 118.2 centimeters squared. All right, next one on the list is number 14. All right, we have a trapezoid. We know that the formula for area of a trapezoid is area equals 1/2 base 1 plus base 2 multiplied by the height. All right, so let's see what we have. We have base 1, we have base 2, and all we're missing is the height, which is right here. Okay, this is an isosceles trapezoid, which means that I can also draw another altitude here. I know that this side length is 13, so that means I have 16 left over, so that means that this is equal to 8. Okay, so we're going to use the Pythagorean theorem to find the height. So we're going to do 17 squared minus 8 squared, which is the same one that we just did. So x squared equals 225. X is equal to 15. So that is our height. So now the area is going to be 1/2 13 plus 29 multiplied by 15, and that is going to give you, not approximate, that's going to give you exactly 315 centimeters squared. Alright, here we go. We have got a kite here. So first of all, let's just talk about the area of a kite is area equals 1/2 diagonal 1 times diagonal 2. Okay, so look at what we have here. We know first of all that this diagonal has been bisected by this other diagonal, so we know that both of those is 2, or sorry, both of those is 10, so we can just write down here that diagonal 1 is equal to 20, just to get that out of the way. Alright, so now we're worried about the length of this side. Okay, remember that diagonals of a kite form 90-degree angles, right? So we're going to do tangent of 21 degrees is equal to 10 over x. So that means that x is equal to approximately 26. Okay, so we know that this is 26. All right, then we're going to do the other side to solve for y. So we're going to do tangent of 48 equals 10 divided by y. So y is equal to approximately 9. So that means that diagonal 2 is equal to 26 plus 9, which is 35. Then if we plug that into the formula, we get 1/2 20 times 35, which gives us approximately 350 meters squared. And I know on your review it says 0.5, but I think when I did those the first time I rounded to the nearest tenth. But as long as you got 350, you're good. All right, on to number 19. All right, so the instructions to this say that these are all regular polygons, which means it's a regular pentagon and a regular quadrilateral, which means that it's a square. First thing we can do is we're finding the area of the shaded. We know that the area of this square right here is 18 times 18. So we know that the area of the square, I'm just going to write it, area of the square is equal to 324. Let's just get that out of the way. Okay, so now we're going to talk about this pentagon. Okay, remember that we're going to draw our center, maybe, our center. And then when you come straight down, that gives us our apothem, or apothem. And then this is going to give us our radius. Okay, so I'm going to go ahead and draw my triangle out to the side. Okay, so first thing we need to do is what is that top angle? So remember, we're going to do 360 divided by 5. Okay, so 360 divided by 5 is 72. So that means that if I have my other triangle here, this whole thing is 72. So that means that this is 36 degrees. And if this length right here is 18, that means that this is 9. So we want to solve for the apothem. So we're going to do tangent of 36 is equal to 9 over x. Okay, so that's going to be 9 divided by the tangent of 36. So that means that x is equal to approximately, let's just do 12.4 for the sake of what we're doing right now. Okay, so that means that the apothem is 12.4, and the perimeter is going to be 18 times 5, so 18 times 5 is 90. Alright, so we plug that into the formula. Area is equal 1/2 the perimeter times the apothem. So that equals 12.4 times 90 divided by 2 is 558. So that's for the whole entire thing. So we're going to subtract the area of the square. And you should get approximately 234 inches squared. I know it's a little bit different on your answer sheet. I think it says 233.4. Okay, all right, on to the next one. All right, so this is the area of the shaded. So the way I like to do this one is I like to find the whole amount first. So if I were to finish this off and just connect my squares. Okay, so let's think about a couple things. It's telling you that each one of these is 1. Okay, so that means my rectangle is actually a 6 by 14. Okay, so 6 times 14 is 84. So that means the area of the whole thing is 84 units squared. Okay, so now we're going to talk about what do we need to be taking off. So we know that in the middle of that thing we've got a square. So the area of the square is 5 times 5, which is 25. Okay, and then each one of these right here is a 1 by 1 square. So each one is worth 1. So 1 times 4 is 4. So when I add up my unshaded areas, that's 29. So I'm going to subtract 29 units squared from this, and I get 55 units squared. Okay, that one's fairly simple. Just make sure that don't overthink it too much. All right, let's see. Parallelogram. So let's draw our parallelogram. Okay, so there's our parallelogram. It says it has sides of 12 and 18, and it has an angle of 68. All right, so let's think about what we need again on a parallelogram. We need length, we need base, and we need height. So that means we need to find the height of the parallelogram. So we're going to call that x. Okay, so we're going to do sine of 68 is equal to x over 18. So that is sine of 68 times 18. Okay, so I'm going to say that that's approximately, x is approximately 16.7. So this is 16.7. So to find area of the parallelogram, we're going to do 16.7 multiplied by 12. And that gives you approximately 200.3, and what are we in? We're in centimeters cubed. Okay. All right, here we go. One of those crazy trapezoid ones. Okay, so area of a trapezoid. Let's go ahead and draw the trapezoid. Okay, the height is 8. Okay, so the height is 8. If the length of the longer base is 12 more than twice the shorter base, what are the base lengths? Okay, the length of the longer base is 12 more than twice, so we're going to say that this is x. That's our shorter one. The length of the longer one is 12 more than twice the shorter, so 2x plus 12. And the area is 168 centimeters squared. All right, so we're just going to start plugging in what we know. Okay, we know that the area is 168 is equal to 1/2 base 1 plus base 2. So base 1, so 2x plus x is 3x plus 12 times the height, which is 8. Okay, so what we can do is we can go ahead and multiply 1/2 times 8. So that gives us 168 is equal to 4 times 3x plus 12. Then we can divide each side by 4. So that gives us 42 is equal to 3x plus 12. That gives us 3x equals 30. So x is equal to 10. So if x is equal to 10, that means that this base is 10, this base is 32. Alright, in a triangle, a base and the corresponding height. So I'm always going to start off with, go ahead and draw my picture. And then here's my height. Okay, a base and its corresponding height are in a ratio of 4 to 5. So remember, it's giving you the base and the height. So that means the base is this one and the height is this one. Okay, so the base is 4x and the height is 5x, and this is our area, is 160. So that means 160 is equal to 1/2 base times height. So 5x times 4x is 20x squared. So I get 160 is equal to 10x squared, divide by 10. So that means that x squared is equal to 16. So that means x has to be 4. So that means that this is 16 and this is 20. Alright, find the area of an equilateral triangle with a perimeter of 48. Alright, so if it's an equilateral triangle, it means all 3 sides are congruent. If it's got a perimeter of 48, that means that each side excuse me, is equal to 16. Okay, remember our formula for equilateral triangle is area is equal to side squared times the square root of 3 divided by 4. So our S is 16. So the area is equal to 16 squared times the square root of 3 divided by 4. So 16 squared divided by 4 is, so that would be 64 times the square root of 3 inches squared. Alright, an isosceles triangle. So isosceles means that these are the congruent. It has a perimeter of 36 and the base is 10. So if that is 10, that means those two sides together have to be 26. So this side's 13, this side is 13. You want to find the area. Okay, so that means you are going to split this down the middle. So if I go ahead and pull out this triangle just so we can find the height. This is 5, this is 13, and we want to find x. Excuse me. Okay, so I'm going to use Pythagorean theorem, so I get 13 squared minus 5 squared equals x squared. That's 144 equals x squared, so x equals 12. So that means my height here equals 12. So the area is 1/2 12 times 10, and that means that the area is equal to 60 centimeters squared. Alright, square equal areas. So let's start with our rectangle. Rectangle is 112 by 63. We want to find the perimeter of the square. So that means that our area is equal to 112 times 63, which is 7,056. If our square has the same area, remember squares have all four sides congruent, so that means that side squared is equal to 7,056. So the side length is equal to the square root of that. So let's do that. So the side length is equal to 84, and they want to know the perimeter, so we're going to multiply that by 4. So the perimeter is actually equal to 336 centimeters. Alright, a car tire covers 589 inches after 6.25 revolutions. Okay, so this one's actually not real hard, but revolutions is the same thing as circumference. So if it goes 589 inches after 6.25 revolutions, we want to know how much it takes to do one revolution. So we're going to do 589 divided by 6.25. That's going to give us our circumference. Okay, which is equal to 94.24. That's our circumference. So now we're going to work backwards, is equal to pi times diameter. Okay, so what I'm going to do is I'm just going to go ahead and divide by pi. Okay, and if you divide by pi, you get the diameter is equal to approximately 30. Roundabout. So when you take half of that for the radius, that means that the radius is equal to 15 inches. Alright, so this one we're looking for arc length. So remember, the formula for arc length is we're going to find the degrees, so 135 over 360, multiplied by the circumference. So the circumference is 18 times pi. When you multiply that out, you should get approximately 27 pi divided by 4 centimeters. Okay, so this one we're actually finding the area of the sector. So we're still doing the central angle, so 150 over, excuse me, 360, multiplied by the area of the circle, which is 576 pi. And when you do that, you get 240 pi centimeters squared. Okay, last one. Okay, this one, don't forget you are finding first the area of the entire piece of pi, then we're going to subtract the area of the triangle. Okay, so of the entire piece of pi, it's going to be 60 over 360 multiplied by 64 pi. Okay, so when we do that, let's see, so this is going to be, give me a second guys. Okay, so when you simplify that, you get 32 pi divided by 3. Okay, so that's the area of the sector. Now we're going to do the segment. So remember, this is an equilateral triangle with a side length of 8. So if we use the area formula, remember it's sides squared times the square root of 3 divided by 4. So we get 64 times the square root of 3 divided by 4, which is 16 times the square root of 3. So our final answer is actually going to be 32 pi divided by 3 minus 16 times the square root of 3. Now you can use your calculator to go ahead and figure that out to get your final answer, but that's how you would find it. Alright guys, well, good luck on your test. Come see me in the morning if you need help. Have a good night.